I'm happy to present to you a case study of the ezValidator software applied to seismic data in the champion field offshore Brunei. I was working on this field some 30 years ago. At that time we were still in the paper and pencil stage, as you can see on my desk. This is a well proposal based on cutting up the sections to check correlations and to unravel the stratigraphy using my scissors. You can follow the green layer in the folded anticline, and this is my unfolded and unfolded layer. The well proposal was successful. We drilled it a year later and found a sizable oil field. Based on this experience, I developed the ezValidator software. I am proud to see that it now forms part of the leading seismic interpretation environment, that is landmark decision space geosciences. The functionality of ezValidator comprises unfaulting, which is getting rid of the faults, unfolding, which is getting rid of the faults, and handling of unconformities. The seismic data of this case study comes from a book we wrote around that time in Brunei Shell Petroleum. The book was later revised by Svein Sandel. This is the basic working of ezValidator. We can draw a fault line using standard interpretation tools, and then we can pick up that fault and place what is called an anchor, which determines the throw at that position. You can move the seismic whichever way you like, but I would argue that this is the correct correlation around the anchor position. If we go up a little bit, we find that this horizon is slightly off, and we place a second anchor to correct for that. We can draw a second fault, which may cross the first fault. And if we place an anchor here, we actually move the whole left hand side of the seismic, and we have the same throw across the crossing fault. Small changes, place extra anchors, and here we have to go a little bit the other way because we are past the crossing point. Now this fault here has influenced the other faults, so we have to correct for that. Now let's go a little bit fast forward. We've drawn with the standard functionality a number of fault lines so that we don't have to do that anymore, and we can now quickly insert anchors in the various faults here. Now this is a special fault. It has a red ball at the end because it's in the middle of the seismic. And that red ball signifies you have a tip point. The movement will be blocked at the end of the fault. You cannot go beyond it. If you want to go beyond it, you have to turn the anchor off. And then you have a lot of deformation higher up because of movement which spills over beyond the tip point. So you're beginning to see light here. We have an event which correlates across. We also have the events up here, the red lines. And we have the events down here which are correlating pretty well. One thing you can do is, when you have a correlation like that, you can draw on the displaced canvas, on the unfolded canvas, you can draw an horizon. With the standard interpretation tools. And the nice thing is, if you go back to original, that horizon is drawn as it should be on the original seismic. You can also let it move from original seismic to displaced, so you can see where your horizon came from, where it's going to. You can also unfold on that horizon. As I said, unfolding means getting rid of the folds. Again, you can let it move from original. And in the unfolded section, you obviously see the stratigraphic correlation just a little bit better than in the folded seismic section. So in a very short time, we have interpreted the left side of our section, and we are coming up with the stratigraphic stories already about this section. So let us now jump forward a little bit. We have done all the faults and we have drawn 4 horizons, and we can see what the displaced canvas is now looking like. As you can see, the correlation is based on the red events at the top, then on the tram lines below that, what we call the tram lines, which peter out towards the left, And then we have this reddish and wide red loop here, which are pretty continuous across. And below that we have firstly here the good correlations, and then here we have the good correlations up to this fault and up to about here. In between we have a zone of jumbled events, which is interpreted by the local geology people as the clay core of the anticline. You can change the display, take away all the faults and horizons, which is often useful to really concentrate on the seismic character. Next step then is to move it, and I'm often inclined to put my feet up on the table, put the display up on a big screen and ask passers-by for comments. Comments on the geology and on the interpretation are both welcome. I would like to draw your attention to this big fault here. If we are an original, then there is a good correlation at the green horizon level, the green horizon, which is having this event here being wide and reddish, and then we have a dull red loop with a loose red loop below. This correlation really looks good, and it took us some time to actually draw in this big fault. The problem with the current correlation is if you draw a small fault, is that if you go to displaced, you also have a good correlation here, and if you would not have the big fault, if you turn it off, you would still have a good correlation here. But then higher up we have two problems. First of all, we have the top of the trend lines, which is very clear set of events, very continuous. That the trend lines are on the right hand side much higher than they are on the left hand side. So we don't talk about just correlating across one fault, we correlate a whole block of geology on the right hand side with whatever is happening on the left hand side. And that correlation here, also here down here we have the more whitish event. The more whitish event has no correlation at all on the opposite side of that fault. So this is the type of discussion you go into with your colleagues. You can say, okay, I can take this correlation where my trend lines are matching and my events higher up are matching, and then this event matches as well. Or I can go for this situation where I have good correlation down here, local, but then higher up there is no match at all, and my trend lines are pretty much offset. So it's an example of the type of situation you get into with ezValidator. You can finally discuss this type of uncertainty. You can bring it up with your managers, and you can ask, you can really throw this open for discussion, which is completely impossible in the original, where your fault blocks go everywhere. Now let us have a look at how ezValidator can help you unraveling the stratigraphy. I would like to point out from the top this event here, which is truncating against the purple horizon here. At the same stratigraphic level, there's also this funny event here, which suddenly goes from a double loop to a single loop. We begin by flattening on the unfolding, on the sea green horizon, which has a very continuous blue double loop below and another blue loop above, which means probably that's been deposited in a quiet environment. If we go up, we see a number of parallel events, both above and below, but they are more localized than below the sea green horizon. We then declare the horizon at the top to be an unconformity, and we flatten it again, we unfold it again. Above the yellow horizon you see constant loops, there's not much variation, but below it we see the unconformity gap in gray, and we see events which, like for example this one ends here, goes across and then ends here. It is not so certain how that happens. It looks like a local erosional event on the right hand side. And if we go further away, then there's reflection terminations around here, and there's thinning overall. This event here is whatever is left of this formation, whereas up here you have a pretty thick package of sediment. This is a little dangerous because if you drill a well down here, you have a lot of formation here, which is disappearing if you go to the left. So if you drill another well here, you would have a fault cutout, a gap in your stratigraphy, which is about half the whole thickness. And the normal reaction of any production geologist is to put in there another fault in that fault cutout gap. So that means that you would get even more faults than you see on the seismic here, which is maybe not such a good idea. Just below the sea green horizon and the yellow horizon below that, we have a similar situation, but again different. We have loop termination here. There's a thinning of the white stuff in between. And then if we can continue here, we lose our triplet. Our red triplet is just probably eroded again by another unconformity at yellow level or close by. So what we've shown you here is the value of ezValidator to unravel the details of the stratigraphy. If you go deeper down, below the trend lines, there is not much change. I mean, we have more or less parallel bedding all the way down to the bottom. So we have these two, probably more small unconformities, and thickness changes associated with that. And it's important to pick that up early to avoid inventing faults where there are none. I've shown you that within a very short time you can validate your seismic interpretation. That's the discussion about that big fault. And you can also unravel the stratigraphy. The ezValidator display is a very good base for discussion with your colleagues, with your management, and especially with external partners. I wish you a whole lot of fun with this software.